The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of Odd Digit Numbers, example 96,721. Let us take one more example dealing with a 5-digit number and find out its square root. Let us deal with this number 96,721. We had mentioned that for calculating the square root, we have to group the numbers from the right side. Therefore, one group is 21, another group is 67, and another group is 9. For the purpose of calculation, we can consider the groups in order as 9, 16, 7, and 21. Let us set the number 96,721 by leaving 3 columns in the right extreme of the abacus. That is, the lowest digit 1 of the number should be set in the thousands column, 2 in the 10,000s column, and the remaining numbers to the left, 7, 6, and 9 to the left. Take the first group 9 and consider the perfect squares there. 4 and 9 are the perfect squares in 9, and therefore we have to take the highest among the two. Take the square root of 9, which is 3. Set 3 by skipping a column to the left of 9. Now 3 multiplied by 3 is 9. That should be subtracted from 9, which gives us the remainder 6,721. In this process, we did not go for an assumed quotient. We mentioned repeatedly that when the divided value is a smaller number, say 1 or 2 or 3, we can simply take it as it is. In the case of the divided number becoming 7, 8 or 9, it is always safe to go for an assumed quotient by reducing 1 from the divided value. In this case, we straight away took the divided value 3 as the quotient instead of going for an assumed quotient. In the next stage, double the number 3 and set the 6 in the extreme left of the abacus. Now consider 67 of 672 and ask how many 6s in 6. You get the answer as 1. In case of small numbers, you need not have an assumed quotient. Therefore, straight away set the number 1 to the right of the first digit of the square root 3 and to the right of the number 6, which is set in the extreme left of the abacus. Now multiply 1 with the 61. That is, 1 multiplied by 6, that should be subtracted from 6, which gives the remaining number as 7 in the second group. Now 1 multiplied by 1, which is 1, should be subtracted from 7. That gives us 6 there. Now together we have 621. Look at the square root now. In this problem, you are going for a third digit in the square root. In every stage of division process, we have to double the square root before going for subsequent calculation. In the square root, we have 31. That should be doubled, and therefore the 61 will become 62. That should be set in the extreme left of the abacus. Now consider 62 and 621. Look at the first digit of the dividend and the divisor. Ask how many 6s in 6 by saying 1. Set the 1 to the right of the square root 1 and to the right of 62. Now multiply 1 with 621 and subtract it from the remainder 621. There is no remainder, and therefore the square root we get is 311.